everyone, my name is Corey Dow and I'm a technical marketing engineer for HP Aruba Networking in the campus switching group. Today we're going to cover updates for AOS-CX 10.13, diagnostics, and MacMove CLI command. Okay, so on the agenda today we're going to have an overview of the feature, the relevant use cases, the configuration, and a demo at the end that highlights how the feature is used. And on to the overview section. So the consensus from customer feedback was that we needed to provide more visibility into MAC addresses moving across switch ports. Customers use rate of change in MAC move counts to identify loops in the network. And prior commands required low-level bash commands and OVS apt-kettle commands to diagnose issues related to MAC moves. In the sample 3 switch topology here, you can see that we have a loop topology where each switch is interconnected with one another. And without spanning tree in this environment, then MAC addresses are going to be looped across the entire environment. So prior commands weren't able to detect rapid rates of moves along the system, and that's what we've done to correct that in 10.13 with a new CLI command. So platform support for the feature, it's been provided across all platforms except for the OVA, and it's new to AOS-CX release 10.13.0005. And on for the use cases, so in the loop topology below, absence of any spanning tree blocking any ports, MAC addresses for H1, H2, and H3 all appear on different switch ports at different times. And lacking any timestamps, it's only known that the MAC address was learned, but not when it was learned, in which ports in this case, where the MAC address has changed ports. So an example of the CLI command that we've added with 10.13, you can see if we're over here on switch 2, and we have a loop topology, and we do a show MAC address table MAC moves, we can see that the current port connected to MAC BB is port 111, but it was previously detected on port 114, indicating a loop in the environment. And then for another topology, so this is the EVPN VXLAN routed topology equivalent. So it's the same scenarios we just covered before, but in a routed topology. So in this environment, MAC addresses may move or occur whenever EVPN VXLAN associations change. So for example, H1 connects to leaf 1 in an office environment, but then moves to leaf 2 when cabled in a different location, office versus lab. So this MAC move will not be detected by the new feature in AOS-CX 10.13 because EVPN itself will first delete the MAC AA if it's found connected to the local port on leaf 2. So in the example below, however, there is also a physical loop present between leaf 1 and leaf 2 on ports 1140, and that will be detected by the feature. And you can see the output from leaf 2 detecting that that MAC had been moved. So the current port is 1140, when that MAC should actually be learned across the tunnel. So you can see the previous port here was learned over the tunnel from VTEP 192.168.0.1. So onto the configuration section. So no special configuration is required for the MAC moves diagnostics feature. It's been added to the existing show MAC address table CLI command. And you can see the previous 10.13 release, the prior releases there's just show MAC address table, but there is no option for MAC moves. But now with 10.13, you can see that we now have an option for MAC moves. And the options that you see at the bottom of the screen, so show MAC address table MAC moves, and then you can also optionally specify the MAC address and or the VLAN to get further granular output as to the MAC move conditions. So the entries will be present as long as the MAC entries in the table have moved at least one time. So if they're detected and they stay in the same state for extended period of time, unless they move to another port, then that won't get detected by the system. The display may be filtered based on the specific VLAN or MAC address, as I just mentioned. And this copy, the support files copy output that support engineers run, it doesn't include the MAC table move, MAC move command. So you want to make sure that if you suspect a loop in the environment, run this command prior to running any copy support files output for the support team, so you can detect the possible loop even before that collection is made. Because again, it won't include this output, but there are other ways to determine if a loop was present after the fact. And so if the MAC addresses are deleted, the MAC move data is deleted as well. So for example, in the cases of EVPN or port security, MAC moves will not be detected by this feature as a result, as the move is performed by the deletion of the MAC address from the old port and installation of the MAC on the new port prior to the move being detected. So since there's a deletion that occurs, the MAC moves feature won't detect that. Okay, and so I have a couple demos that I'm going to show you just from the use cases and examples that I provided before. So in the first case, we've got a loop topology with spanning tree disabled and pings going from H2 to H3, and we're going to show the MAC moves across the ports in the three-switch topology here. And then for feature demo 2, we're going to have the same use case we described before with the EVPN VXLAN routed topologies, pings from H1 to H2, and also with a physical loop in between 1140 between leaf 1 and actually leaf 2. I need to correct that. And we're going to show EVPN MAC moves across the VXLAN tunnels and the physical ports in the topology. Okay, so we're going to show you demo 1. And so this is the loop topology that we have in the environment. We got 3 switches, as you can see in the topology diagram at the bottom. They're all interconnected with just VLAN 1 in between them. And I believe we have spanning tree enabled to start with. We'll see that in a moment as we go through the demo. And so we have the 3 MAC addresses, as you see there. Well, it's a little bit hard to see, but H1 is MAC address ending with AA, and then H2 is BB, and H3 is CC. And you can see that reflected in the MAC address table that you see up here at the top. And so we'll show you just what the environment looks like. Well, you can see the IP addresses involved here too. So ETH1 is on HS1 has 192.168.0.1. It's not configured yet on HS2, so we'll configure that as we move forward with the demo, and then 192.168.0.3. And so we're just going to affect some pings across the environment and to show how the MAC moves is able to detect the loop at rapid rates. So again, just showing the MAC addresses and where they're learned, as well as the LLDP information for where the ports are connected, which matches the topology that you see at the bottom of the diagram. And again, just showing you the MAC addresses on each of the Ubuntu systems that are in the environment. Okay, so now we're going to start some pings back and forth just to get some network activity going. And this is where I had forgotten to configure the .2 address here, so I'm just going to configure that really quick and start pings across to all 3 of the hosts in the environment. Okay, so we clearly have network connectivity in the environment. And so this is where we're going to take a look at the MAC address table and the MAC moves command for the first time. And so at this moment, we haven't detected any MAC moves in the environment. And I believe the reason this is the case is because we have spanning tree enabled on these switches, so there is no loop at this moment. Yeah, so that is the case. So we're going to go in on switch 1, 2, and 3 and disable spanning tree. Same on switch 2. And same on switch 3. Okay, just looking at the MAC tables again. And so you can see that switch 1 is connected to switch 3, so this topology is now looped. Start some pings again, get some network activity going. And now we should start seeing some MAC moves across the environment. And yes, so we see our first MAC move there for one of the MACs in the environment. See the move count is 196, so we're able to detect rapid rates of MAC moves, which was not available in prior releases. And now you can see where just after a few seconds, we're really starting to see additional MAC moves. I mean, it's being multiplied by nature of the broadcast storm in the environment. And I believe that's coming close to the end of this demonstration, and now we'll switch on to the EVPN VXLAN equivalent. Okay, so now we're on to demo 2, which is a different topology. This is the EVPN VXLAN topology, where you can see that we have 2 leaf switches at the bottom of the screen here in the topology and 1 spine route reflector, as well as 2 clients, H1 and H2, with MACs corresponding to AA and BP. And so in this demo, the clients are connected to VLAN 10 through symmetric IRV. And we also have the loop topology that you can see there connected between leaf 1 and leaf 2. Ports 1140 and 1140 on leaf 2 are both interconnected as an accidental loop in the environment. It's not a topology that anybody would want on purpose. Okay, so we'll just move through the demo. And just have the physical topology shown at the top through the LLDP neighbor table. And just showing the MAC address table to begin with. So that we can see that the MACs are learned in both cases correctly as they should be through the physical port and through the VXLAN tunnel. And just covering some of the VXLAN configuration, just showing that our tunnels are up and back, are up back and forth between leaf 1 and leaf 2. And just showing the running configurations for VLAN 10, where we have the symmetric IRV gateways, each with 10.1.1.1 as the gateway. And so just verifying that we can ping back and forth between the 2 endpoints in the EVPN VXLAN topology. So everything looks good at this point. Okay, and this is actually from a prior instance where I had 1140 enabled. It's not enabled at the moment. So we do have a prior instance where we were detecting the loop in the environment, as we can see there. Rapid, yeah, so this is where we're going to get it current, where we're unshutting the 1140 interface. And we'll see that the MAC moves are incrementing on both leaf 1 and leaf 2. So that's the end of the second demo, and hopefully this was useful. And I'd just like to thank you for joining this session. If you have any questions based on this content or the future, please do feel free to reach out to us at any time.